Here's a geometry problem. We've got a regular octagon here attached to a regular pentagon. Octagon 8 sides, pentagon 5. And they say that the perimeter of the octagon is 120. So we can work out the length of side DC because it will be 120 divided by 8. 8 goes into 12 once, leaving a remainder of 4. 8 into 40 goes 5. So this turns out to be 15. So we can pop that on the diagram there, 15. Which means all of these sides are 15. We know that this side is 15, and we know that this side is 15. So this triangle here is an isosceles triangle where these two angles, I'll do the angles in red, these two angles down here are equal. We need to find something about the angles around this point. Now, I always think the way to get to interior angles of any shape is to work out the exterior angle first and then take it away from 180 degrees. So the exterior angle of an octagon is simply 360 degrees divided by the number of sides. 8 into 36 goes 4. Remainder 4, 8 into 40 goes 5. And therefore the interior angle is equal to 180 minus 45, which is 135 degrees. We've got this angle here as 135 degrees. Okay, let's do the same for a pentagon. 5 goes into 36 7 times, remainder 1. This turns out to be 72 degrees. So the interior angle is equal to 180 minus 72, which is 108 degrees. So I can pop that on the diagram, that this angle here is 108 degrees. Well, that gives us this angle. So I can say that angle ADB is equal to 360 minus 108 minus 135. And this turns out to be 117 degrees. So this in here is 117. And as I've said before, we've got the lengths AD equals the length DB, and they both equal 15. So let me redraw this triangle slightly larger now, and let's pop onto this diagram exactly what we've got so far. Well, the simplest way to do this is to drop a perpendicular down and create a right angle. Now we've got a right angle triangle, we've got 15, and we can work out the length of this side. So let's call this side, well, X. If you are that angle and you look out towards the side, it's the opposite. And the other side that we've got is the hypotenuse. So it will be the sine relationship. So I can say that the sine, half of 117 is 58.5. The sine of 58.5 is the opposite, which is equal to X, divided by 15. So without doing anything to the calculator, just muck this around and get that X must be equal to sine 58.5 multiplied by 15. And if you work that out, you get 12.7896 and so on for X. But we're not quite there because X is half the result we need because AB will be double X. Therefore, AB, which is the length we want, is 2 times X, which is equal to 25.5792. And because all of the figures we've got in this problem are quoted to integer values, I think it will be reasonable to chop our number off here. So rounding the number, we get 25. Well, if we're going to chop 792 off, we have to bring this 5 up to a 6. And this is in centimetres. And this is to 1 dp. And that is your answer.